I want to cover basically very broadly the impact of aquaculture on waste output and eventually environmental impact. Aquaculture has been an industry that's been growing. I saw that figure. You may have seen it a million different times. Aquaculture is one of the food production sector, the animal production, food animal production sector has been growing over the years. And aquaculture products are now part of our diet, right? When I was a kid, we eat chickens, pig, pork, and beef, but we didn't eat tilapia, we didn't eat shrimp, we didn't eat salmon, etc. Where today it's widely spread. We can find it in every supermarket, in every restaurant. It is a staple food of our direction. So aquaculture is playing an important role in the food supply in the US, Canada, and Europe and elsewhere. Environmental impact of aquaculture is a hot button issue. I like to think it's because it's a little bit of a new kid on the block, right? It's not been there, so it's new, so it's kind of visible and quite popular in the press. So it often gets hit with stories about the negative environmental impact of the industry by various NGOs, associations, and people that have a vested interest in speaking against aquaculture because they have a cottage located near a fish farm or something like this. So there's a bit of conflict in the industry. So the environmental impact of aquaculture is always kind of a fairly hot button issue. And some of the criticism are well-deserved because a significant number of aquaculture operations open in open or semi-open system. You have net pens which release their waste in the oceans and bays, rivers, and lakes, and etc. So basically, they have to be good environmental stewards. So we need to keep a close tab on what they're doing at the same time. The impact of aquaculture operation on, in terms of greenhouse gas emission or things like that, has been quantified. There's a number of good studies. And overall, the aquaculture industry is a small contributor to the carbon footprint, to global greenhouse gas emission globally from the agri-food system. It's really quite limited. It's basically similar to sheep production, which is really quite small. So only about 0.49% of anthropogenic greenhouse gas emissions. So it is small, but not negligible. And the industry is committed to reducing the greenhouse gas. One of the things that I find is challenging when talking about aquaculture is the great diversity. We have over 350 fed species. That doesn't count the species that are filter feeding or you don't feed. So we deal with many different kinds of animal species. They go through a metamorphosis in many cases, so they have several life stages. And the feed use for these species is very diverse. I like to think a little bit as dairy feeds, right? You can be so diverse. Ruminant feed can be so diverse. Well, I like to think of aquaculture feed as being so diverse. It's not your typical corn and soy diet. They're actually they're diverse in ingredient composition, but also in the way of serving the diet, from trash fish to wet, moist feed to the most advanced pelleted feed. So we have everything under the sun in aquaculture. So when you try to say, well, what is the environmental impact of aquaculture? So what kind of aquaculture you're talking about? Which species, what production system, stuff. And a number of researchers have tried to do this and estimate the things, and you can see it's highly variable. It goes from about 3 kilograms, right, of greenhouse gas emission up to 18, just simply at the farm level. So it's highly diverse as a function of the species, as a function of the production system, as a function of the region where it is produced and the conditions and all the socioeconomic conditions under which the fish are produced. I was collaborated on the studies that try to estimate nitrogen and phosphorus waste output from aquaculture operation globally and try to map the future and determine where things are going to go. So we generated 4 different scenarios, basically business as usual, or the industry becomes like very virtuous and they adopt all the best practice and etc. And we came out with estimates, and that was based on hundreds of different parameters. And in the end, it was a lot of guesswork, just rule of thumbs, basically ratios, stuff, or things like that. Because of the diversity of the industry, that's the best thing we could do. And we still had to parameterize like very extensively. And we generated realistic estimates of nitrogen and phosphorus waste output, partitioning by the animal, etc. But basically clear from that work is that aquaculture is so diverse in terms of production system. You have these net pen farm where I come from, Ontario, where we have just basically net pen suspend, no aeration, hardly any equipment. They go on a boat and they feed the fish a couple times a day or sometime once a day. And that's basically it. Up to the super modern recirculation aquaculture system with liquid oxygen and things, constant flowing of the water, pumping of the water, recirculating the water to treat the metabolic waste, convert the ammonia into nitrite and nitrate, etc. You have production in Asia, which is simply a hole in the ground. You got an air-breathing catfish species. So in Indonesia and in West Java, they dig a hole in the ground. It gets filled by during the monsoon. And basically, you put the fish in there and you don't invest in any energy per se. And then you have the modern shrimp farm, which is, I call a washing machine, where you got aerators and everything going at the same time. You got transparent animals, you don't see them, but basically there's thousands, hundreds of thousands of animals in that thing, and you don't see the animals, and you invest a lot of energy and effort. And farmers pour basically all kinds of input there, from probiotics to chemicals to all kinds of extra vitamins, etc., in there, which contribute to the environmental footprint of the operation. You got these aquaculture operation in Vietnam producing basa catfish or tra catfish, where actually basically, right, you see there's no tractor, no mechanization. Everything is, they pull on the rope, on the raft. They basically have a silo, they dump the feed on the raft, and then basically there they go. So the environmental footprint, or the basic contributor is the feed. It's not the energy that they use. They're air-breathing fish. They don't need aeration. And then they're located in lowland, the Mekong Delta. And when the tide rises, they basically open the sluice gate. It basically is like flushing your toilet. They empty the pond and fill up with new water. And that's basically it. So bye-bye, the wastes are gone and you don't worry about them. So in this case, feed represent the bulk of the global footprint if you simply look at the farm, kind of the farm picture by itself. The other end of the spectrum, like I mentioned, you got the recirculation aquaculture facilities that pump water all the time, inject oxygen and stuff like that. Everything is concrete over or fiberglass over, etc. So basically, the footprint of these farms is much bigger, the infrastructure and energy used. And the feed then represent less than 50% of the carbon footprint of the farm, because of all the energy that are used and in the construction and the operation of the facility. So it's really quite different from system to system. I was involved for many years in estimating waste output from aquaculture, where we determine over decades of work actually and tedious field work, is that you can very easily estimate waste output using simple nutritional principle. And you guys, nutritionists in the room, you know this, right? You feed a certain amount of feed, it's made of X, Y, Z. You can predict the digestibility. You look at the animal consuming the feed, you know how much biomass is produced, you know the composition of that biomass. You can estimate waste output. It was difficult to convince people that you could do this, but basically through careful work, we demonstrated it worked, including about 10-year project with 5 production cycle plus like a year before and a couple years after of following up a farm located in a 10-hectare lake in Northern Ontario. And basically what we're able is using nutritional model, we're able to predict very exactly, very accurately how much waste output was coming out from the farm. They installed traps under the net pen to collect the fecal material. And basically here, the solid phosphorus waste output estimated from the fecal trap and our model were identical. However, what was very strange is that the manure fell from the bottom of the cage there, the net pen, to this. They mapped the sediment very carefully, and you see a manure pile, and it's very well defined. And they could only find 5% of the phosphorus where we expect. So it was 43% of the phosphorus that should be found there. So that led me to believe that basically it's very easy to predict waste. It's a completely different business to predict environmental impact. So we cannot just get too cocky and says, well, we can predict waste, then we can predict the consequence. We cannot. It requires a much more complicated science. So even in that 10-hectare lake, we could not predict environmental impact in terms of very well. But basically, we can predict waste output very accurately, and I've been replicating this work with tilapia, with shrimp, with pangasius, with whatever species you want. We can very accurately look at how much input right? How much inputs we have in the farm, how much oxygen, for example, the animal will be grabbing, and how much CO2 they'll be putting in water, how much solid waste, phosphorus, ammonia, etc. So we can do this and then explore the impact in using models and simple simulation, the impact of enzymes or any feed additives or changes in ingredients or change in feed manufacturing practice or production practice, and basically estimate the reduction or the impact on waste output. For shrimp farm, I can mention there's lots of energy input through aeration, a lot of recirculation of water, lots of addition of product. That takes really quite a bit more, I guess, complicated in a simple net pen where you feed and you look at the input, but still it can be done. And for this case, this researcher estimated a carbon footprint of shrimp farm to be about 7 kilograms, and feed only represented about 23 kilograms of this. All the energy that was used to aerate water, all the different things including the processing and the shipping of the shrimp, was really quite important. One thing that we noticed working with farms is that actually there is big improvement that can be made in the production practice. And I illustrate this with this simple example. They have problem of mortality. It's not only that species. I heard today, right, even swine in China that have a high mortality. Well, they experience high mortality. We know that mortality will affect FCR, right? The animal consumed feed, it dies, so it will impact your economical FCR. But when we compare our model simulation of the impact of mortality on the FCR and what was happening on the farm, we found this huge gap. So basically what's happening is the farmers still think the shrimp are still there and they still feed according to what they think the number of shrimp there is in the pond, right? So there's great scope there for improving feed management practice and having models that predict the feed requirements of the shrimp, estimate the inventory. And that's the major problem is estimating the inventory. The red dots are the farm estimates, and then the blue line is our model estimates. And basically, you can see the great difference. The farm doesn't have any idea to basically go and estimate the number of shrimp out of thin air, and basically sometimes use that information, right, and leads to overfeeding. So basically, the farms need tools. So that's why I contributed to co-founded a company that is developing the tools to manage the feed, all the complexity of the feed ingredients formulation, the origin of this, and formulate feed on a carbon footprint or other environmental metrics, but also a farm software that helps with the production and feeding measurement, data compilation, data analytics, but also recommending feeding management and this, and creating an ecosystem where the two systems can be linked together. I think Dr. Fergat was mentioning this. We need a system that integrates together. We need to connect the feed and the farm and all this. And it's not only the farm, right? These products will go in. There's inputs that come from elsewhere. There's the final products that are going to go to the processing plant and shipped over. And I was reading a study where they're comparing RAS-produced salmon versus cage-producing salmon. Cage-produced salmon is much lower environmental footprint than the RAS system. But if you take into account that these salmon farms are located in Chile, Norway, the Faroe Islands, in the UK, and then shipped to the US, when you take into account the shipping, then the RAS system actually becomes equivalent in terms of carbon footprint to the cage farm, and it can be produced locally. So there's going to be a lot more work on this in the coming years. Thank you very much.